Welcome, homeowners and future electricians. Welcome to another episode of Homeowners Electrical Professor. My name is Paul Spasti and I am your host. Today we're going to discuss some basic electrical theory for residential. I'm going to introduce some basic electrical terms like voltage, current or amps, resistance or ohms, watts, kilowatt hours, conductors, which are basically wires versus cable, series circuit, parallel circuit, overloads, short circuit faults, and ground faults. I have a little motto I've always taught to younger people. You don't have to be afraid of electricity, but you do have to respect electricity. The first basic law of electricity is called Ohm's law, and that dictates that the current, the voltage, the current, and the resistance. Ohm's law states that voltage is equal to the amps times the resistance. You can use algebra to find out the other quantities. There's also Watt's law, which is voltage times amps, also a little bit of algebra. Sometimes watts is referred to as power. An electrical load can be anything that consumes electric, like light bulb, hair dryer, toaster, anything at all. We're also going to talk about eventually kilowatt hours. When you have watts times the length of time, that determines kilowatt hours. When the number becomes larger than 1,000 is when it is expressed as kilo. Kilo equals 1,000. This is part of how your utility bill is calculated as usage. Now we're going to talk about electrical circuit current flow. When an electrical circuit is operating properly, current will flow through insulated conductors. Conductors will be inside of an electrical cable. More on conductors and cables later. The amount of current flowing will be determined by the voltage and the resistance of the circuit, Ohm's law. The resistance will be determined by the load on the circuit. The residential voltage will either be 120 volts or 240 volts. And these voltages are just nominal. The utility might be a little bit more, a little bit less, depending on the time of the year. Residential electrical conductors and residential electrical circuits, there are three basic types of conductors: the hot or the ungrounded, the neutral or the grounded, the ground or the grounding. The hot conductors will be insulated, usually black or red. The neutral will be insulated, always white, and the ground wire may be bare or it may be green. Now, conductors and cables. Basically, conductors are the individual wires within a cable assembly. There are different cable assemblies in residential electricity. There's NM cable, it's also called Romex or Flex. There's armor cable, sometimes called BX. There's metal clad cables. This will be discussed more later. Residential electrical conductors, remember the hot, the black or the red, and neutral white conductors are current carrying and will always be insulated. The ground, green or bare, should only carry current during fault conditions. We'll do more on fault conditions later. A summary of residential electrical current flow. The normal flow of current in a 120 volt circuit is out of the circuit breaker through one hot conductor to the load and returns on the neutral conductor to the neutral connection in your electrical panel. The normal flow of current in a 240 volt circuit is through one of the hot conductors to the load and returns on the other hot conductor to your electrical panel. More on panels and circuit breakers later. In summary, 120 volt circuit, one hot conductor, one neutral conductor. 240 volt circuit, two hot conductors. Here's a pictorial of a 120 volt circuit breaker, a hot or ungrounded conductor through the load, comes back on the neutral. I didn't show the green or the ground wire just for simplicity. A 240 volt circuit, a 2-pole circuit breaker, the black wire, the load goes out. On the red wire, it comes back. Now, in a piece of two-conductor cable, which we'll go over later on, a black and a white, you can, under the National Electrical Code, take the white wire and identify it as black with tape at both ends. There are three basic types of electrical circuits in a residential wiring. There's a series circuit, parallel, and a combination of series and parallel circuits. A series circuit, a good example of a series circuit is a switch or switches in series with a light. The electrical current has to flow through the switches to illuminate the lights. Therefore, the switches and lights are in series. Here's 120 volts, here's your switch. If the switch is open, no current is flowing. If it's closed, it flows through the hot conductor, through the light, back on to the source of your 120 volts. A parallel circuit, a good example of a parallel circuit is receptacles in your house. You can plug in a load into any receptacles and you will get current through the load. If you plug in loads at more than one receptacle in the same circuit, the total current in that circuit will be the sum of currents at each receptacle. The receptacles are available independently of each other. Here's your 120 volts, here's your hot wire. It feeds both receptacles, and then both receptacles have a return path through the neutral. A series parallel circuit, an example of a series parallel circuit is the receptacles in your house wired in parallel so that each receptacle is independent of other receptacles. Then a branch off of the circuit can feed switches and lights. The switches and lights part of the circuit are wired in series with each other. The switches and lights are wired in parallel with the receptacles in the circuit. So here's our parallel circuit of receptacles. Then we branch off, we have a series circuit with a switch and a light, and they all return on the neutral path right here.